Ladies and gentlemen, welcome to the Thought Leadership Forum that we are starting off now. Thank you for taking time out to join us today. Morning meetings always tend to be a challenge given the traffic situation here, but I'm glad we have a standing room only hall today, and I think, Ron, that's everyone's looking forward to the very provocative topic that you have for discussion. For those of you who don't know me, my name is PVG Menon. I'm the president of IESA. There are some new faces here, which is very, very welcome. This particular topic couldn't be more opportune in terms of timing, because as IESA, we have been looking at how do we grow the domestic electronics industry in India, how do we take India and position it on the road to self-reliance in electronics. As most of you would know, and this is the study we put out in January of 2013, India's first ground-up ESDM report, 65% of the electronics that is consumed in this country is outright imported. And of the 35% that is manufactured here, less than 10% is what we call as high value add manufacturing. And therefore, bridging that gap between what we consume and what we produce is vitally important for India. As all of you would know, the journey of ISA has increasingly taken a turn where we're saying semiconductors is at the heart of driving the electronics revolution for self-reliance in this country. And a topic like today's, where we are talking about the economic evolution of the semiconductor industry and the implication on design and innovation, becomes very, very timely, and I'm looking forward to a very thought-provoking discussion. Because our ambitions are, as we've always said, over the next decade to grow 200 world-class product companies and 50 world-class fabless companies out of India. What does that journey entail in terms of intellectual property, in terms of innovation, and how can we transition from being, shall we say, the global service provider to the world to being a country which has ambitions to develop products of its own. And the intent of forums like the Thought Leadership Forum is to get in global leaders who bring a new perspective on how India's problems play out and what are our ambitions as we embark on this very, very interesting journey. So I am, some of us in the ISA Executive Council have had the privilege of meeting with Ron a couple of months ago when he had made a brief trip to India. And it was a very stimulating dinner conversation, and I'm very, very glad Ron, for taking time out in your schedule in this trip to address the larger industry. So I'm not going to take too much time here. Let me very quickly introduce Dr. Ronald Black, President and CEO of Rambus. Dr. Black has over 20 years of experience managing businesses and running companies in global semiconductor and mobile markets. As President and CEO, Dr. Black provides overall vision and leadership necessary to drive future growth for the company. Prior to Rambus, he has held positions as CEO for MobiWire, formerly Sagem Wireless. He has also headed Wavecom, a publicly traded French wireless solutions company, and has also held positions with Gear, Motorola, and IBM Electronics. And Dr. Black is a distinguished alumnus of Cornell University, from where he's done his bachelor's, master's, and a PhD in material science and engineering. So, ladies and gentlemen, please welcome Dr. Ronald Black.
Thank you. I forgot my little clicker. Don't take my seat.
No.
That's my name. Maybe I won't use this. I'll use the manual clicker. So yeah, the title of the talk, thank you very much, is Economic Evolution of the Semiconductor Industry. When I was at Cornell studying, my core studies were in engineering, science, math, My minors were in applied mathematics and also economics as an undergraduate. And between economics and engineering and science, I much preferred economics. And the reason I much preferred it is that there was rarely, if ever, controlled experiments, which means that you can pontificate on any topic, you can torture data into any set of facts that you want, which is why most of our politicians do it regularly, right? At least they do in the US, I'm sure they do it here in India as well. The beauty of it also is that it's required in some ways to underpin a lot of what we do. So you're going to hear me pontificate about a few things. I will try to keep the pontifications short and more in a factoid statement. There are going to be a few small commercials in here, right? Krishna required that I talk about Rambus a little bit. I'll try to make it small and in the context of what we're talking about here. I'll cover the following things: a little bit on technology and design trends, the implications for semiconductor IP creation and IP-focused companies, and that's what we are, right? I met one of your colleagues who's in the space as well. A little bit on the implications of the startup culture, because I think the startup culture has changed dramatically over the 20 years. I've been running a variety of different startups over the years. I think there's also implications on what you do, what we do in the India Design Centers. And I think there's a few things to think about as you embark upon the bold attempt to realize a lot of the growth from the semiconductor industry and in fact invest in fabs, which I suspect is happening. I'm told it's almost a fait accompli at this point. So let me start off from the beginning. I think we, as an industry, have been blessed with the evolution of semiconductor technologies since 1972. In the phrasing, I'm quite old now. I feel old as I approach 50 years old, but I was only a very youngster in 1972 in second grade, and I didn't know what a semiconductor was, although I knew I wanted to work in the scientific field. And we've really embarked in a fantastic evolution through these many years, and I think it's going to continue for a long time through the new materials, advanced lithography, and incredibly expensive fabs. The difference is, as I think many of you have found, is very few of the semiconductor companies anymore can afford it because the availability of capital is really not there. In fact, I would say Intel, Samsung, TSMC, and Global Foundries are really the only ones that can really afford to develop process technology on their own and scale it. Everybody else has to partner in some ways. I've worked for or with companies that have not understood the economics of this, and it has not bowed them well in the future to be able to have deep pockets and continue to evolve. But it is continuing to evolve, and I think it will for the foreseeable future. Everybody knows Moore's Law, and it continues. It is maybe stressed, but it's incredible with the design teams, the innovation that we have, the novel architectures, the way people are finding the ability to continue to increase performance through multi-cores, really refined software. So much more of a system solution standpoint. But most of all, and underpinning that, is the market need and the market demand for continued performance improvement as the transistors continue to go up. So I think we are going to continue to see lots of really great products in the future. On the other hand, from an economist's perspective, there are some really, really deep and challenging problems, which, as I'll describe later, I think ripple through at least what we do in the IP creation, I think what everybody will be doing in the future. And the first is this very non-linear problem of wafer costs. When I first started out, I remember we would spend $250,000 for wafer for mass set, and we thought, well, $250,000, that's a huge amount of money. It's slightly more expensive now. It's millions, and it's projected, as you have to go to these really DPV technologies, to be tens of millions. So what does that mean, really? As a designer, as a design team, having been mostly involved in the design side through my life, it means if you make a mistake, if things are not done well, this is not a small issue. It's a devastating issue from a financial standpoint. And this is only going to get worse, and I think it will ripple through absolutely everything that you find. I'll talk about it later. A lot of what I've done on the startup side, it's already affected it dramatically. In fact, it's dried up a lot of VC-based funding for semiconductor companies. Another problem, and actually I got this chart from some of my team who had gotten it from a presentation from NVIDIA, is that we may be experiencing a transistor cost asymptote. So what you have here on these slides is the relatively cost for different technologies. I know it's hard to see, but you can have get the copy of the presentation later on. And the last two dotted lines, and this is from 2 years ago, are 28 and 14 nanometers. And what it shows is that it goes down, but just basically overlays the 28 nanometer benchmark. So you're not having a consistent decrease. What my smart technologists have said is there will be cost decreases. It's just going to take time, and the 28 nanometer node will last longer. However, it means that if we are starting to space out these technology nodes, changing IP as an IP company, right, will become less frequent and will be more important. So the probability of changing IP once you have it right, given how expensive it is something that you're going to really have to think about as you implement designs. And that, of course, is what flows through, right, the entire semiconductor industry. So here's another set of data that I think is very important. It's from the Semico Research IP Subsystems, The Race is On, in May of this year. And what they looked at is a cross-section of a lot of SoCs. And they looked at the number of IP blocks on average in those SoCs since 1998 projected through 2016. And what you can see here in 2013 were about 90 blocks. So the semiconductor companies, the SoC approach, is to leverage the IP industry. And I think you're going to see this increasingly, right? If you step back 25 years ago, ARM embarked on a very different strategy. I was in the processor business, right, both at IBM and Motorola. And we were confused about ARM, this tiny little company that really shouldn't have been able to do things, has done an absolutely fantastic job in creating a IP-orientated business. And just to put it in prospect, the company that I now run was multiple times bigger than ARM in market capitalization, about 10 times bigger 10 years ago, could have easily acquired ARM. And now ARM, despite the fact that we've done rather well over the last year that I've run the company in doubling the stock, ARM still has a market capitalization that is 20 times larger than ours. So the power of the IP model that ARM has embarked upon and really driving the IP business is absolutely incredible. It's really hats off to that company and all of the others that found it. But I think that with the IP base that we're describing here and the increasing number of IP blocks that you use, there is a huge advantage for reuse, right? And there's a huge advantage or problem of opportunity costs.